this we have to prove. To prove here, this is the volume. So here cardioid is, let me just put the cardioid here. So if I put 0, this is twice A. At 0 it is twice A. This is twice A 0. At okay, and at pi, if I cos pi is minus 1, so 1 minus 1 is 0. At pi it is 0. Alright, so then at pi it is 0 and it is twice A. It will be this kind of cardioid is obtained. This is the cardioid here. Here theta equal to 0. Here theta is pi only. Okay, so this is twice A. Here the point is twice A 0. And here it is pi by 2. This is minus pi by 2. In this case, this is 0 here theta. And if I take this area theta pi by 3, theta minus pi by 3, minus pi by 3 theta equal to. Okay, so in this way we have to generate it. Now this illustrated from 0 to or minus pi by 2 to plus pi by 2 is a revolve around. If I write suppose 0 to pi by 2, if I take the limits, and this solid is revolved around initial line at theta equal to 0. That means this is the initial line here. So if the volume of this is obtained by, when we know that in polar form, okay, the volume of the solid generated, let me write the formula here, of the solid, of the solid generated by revolving the area about initial line. This is initial line here. About the initial line is given by, we know this is given by 2 by 3 pi sine of integration 2 pi by 3. It is now in this case 0 to pi by 2. Limits will be taken here 0 to pi by 2. So this is within this. If I multiply this by twice again, that will give us the whole volume. But this 0 to pi by 2, this only cardioid is revolved around initial line. So initial line, this is the initial line. This curve 0 to pi by 2 is revolved around. Okay, so that is the point here. That is given by RQ into sine theta d theta. That the formula we always write here. Okay, so this is RQ sine theta d theta. This we have described in the previous, initially when question number 1. This is question number 1 type, just because here is the volume of the within limit 0 to pi by 2 we have to find out, because minus pi by 2 to pi by 2 only limits are given us, or theta line between minus pi by 2 plus pi by 2. That means 0 to pi by 2 if I find, then the solid will be generated. Okay, that is the solid we have to find out. So this is the volume we have to find out. R is this value. Now let me substitute. Therefore volume is equal to 2 pi by 3, 0 to pi by 2. Here in this case, the 0 to pi by 2. RQ is AQ from first equation into 1 plus cos theta whole cube, RQ here, into sine theta d theta. Simple. Now if I substitute 1 plus cos theta as t, let me change it and integrate it within time. So that will give us complete integration. Let me just find out this. So putting here, let me solve it by assuming something, so it will take less time then. Let putting 1 plus cos theta, which is in the within bracket, 1 plus cos theta is equal to t, let me take. It will be minus sine theta into d theta equal to dt, differentiating it with respect to t. With respect to t, we get this value minus sine theta cos d theta equal to dt, or minus we are defining with respect to t here. So it will be minus sine theta d theta upon dt equal to 1, and dt taken to that side, or sine theta d theta equal to minus dt. The limits here we type for the limits here. At upper limit pi by 2, at theta equal to pi by 2, cos pi by 2 is 0, t equal to 1, t is equal to 1 in that situation. What when 0 at theta equal to 0 lower limit, when theta is 0 here, if I put 0 in this case, cos 0 is 1, so 1 plus 1 is 2, t is equal to 2, limits are 2 to 1, but negative sign is there, no problem. Therefore the volume will be, in this case, therefore volume equal to now new volume 2 pi by 3. This is 0 to, sorry, not 0 but 2 to 1 now. Minus sign is obtained because this is minus dt. Where is that? This is minus dt here. Sin theta is sin theta d theta. Sin theta d theta equal to minus dt. Negative sign I have taken out. And this is now aq. Let me take outside. 2 pi aq. aq this I have taken outside. This is tq into dt. tq into dt only. Limits 2 to 1. So this is the new volume. Let me now integrate this tq with respect to t here. This is, if I take minus sign positive, it will be 1 to 2 limits. Limits will be interchanged. It will be 2 pi aq upon 3. Now limits, let me write 1 to 2, because when this minus sign is to be changed, then limits can be interchanged. It is lower limit has become upper limit has become lower limit. This is 1 to 2 now. Okay, this is tq into dt. Integration now can be done. Is 2 pi aq upon 3. Integration is t4 upon 4. Limits 1 to 2. Let me now substitute this 2 pi aq upon 3 into t4, or 1.4 can be taken out. Let me take, this is 4 here, this 4 are taken outside, and now t4 is 2 4, that means 16. 2 raised power 4 means 16 minus 1, because 1 raised power, now lower limit is 1, so minus 1 here, but 1 power 4 is 1. 2 raised power 4 is 16, 2 into 2 into 2, 4 times, 16 minus 1, it is 15 now. It will be 15. Let me now solve it. Therefore the volume obtained is, therefore the volume of that cardioid or solid obtained by revolving the cardioid about the initial line at theta equal to 0, or initial line, is given by, this is 2 into pi aq upon 12 into 15 now. So 3 4 is 12, 3 5 is 15, 2 2 is 4, it is 5 by 2, okay, sorry, 2 6, this is 3 4 is 12, okay, 5 by 2, 5 by 2, alright, this is 5 by 2 pi aq, same answer is obtained. So this is the volume of the solid by solid generated by revolving the cardioid about the initial line. About the initial line where theta is 0. With the 5 by 2 pi aq, the same answer is obtained. This is 5 by 2, 2 to the 4, and this 12, 15 by 12 was cancelled by 3, divided by 3, numerator and denominator, 3 5 is 15, 3 4 is 12. 5 by 4, but 2 pi aq was there in the numerator, 2 to the 4, so 5 by 2 is obtained. This is the answer here, hence proved. This is the volume of the solid in the solid obtained by revolving the cardioid around the about the initial line at theta equal to 0, where theta is 0. Theta is 0 at initial line. So this is the answer which is 12th question says. Okay, 12th question says that this is the answer we have to prove. Now we have proved that 5 by 2 pi aq is the volume of the solid in the okay, by the cardioid, generated by cardioid, revolving it about the initial line. That's all. So question number 12 is completed. Okay, so this ends polar equations, volume of solids of revolution by polar equations or from polar equations. Okay, so this ends this topic. Okay, up to this point here we have done. Okay, now next see you in the next lecture series, which is further of this. Okay, next topic is to take discussed here. All the questions are done here with illustrative examples, with illustrative questions here. All these questions are taken from the students' queries. So please see or write me some more questions, whatever your queries are there. I'll try to solve them. Okay. Mostly I take students' queries only. Okay, whatever queries are there, either online or in the classes study. When we teach the class, okay, students in the class for engineering or for MSc or BSc students or management students, MBA, BBA, BCA, MCA, and all those students, I'll take those topics next. I mean for MBA and BBA also, MBA, BBA, BCA, MCA. So all those topics I'll take later, but at the moment I'm taking these topics for science students, for engineering students, BTech, MTech, or BSc or MSc students. Okay, all those students who are studying mathematics as their main subject. Okay, so that is for BSc honors, BCom honors, or whatever. If they are studying mathematics as subject, that is for them. University students mostly. Okay, if there is any query, please ask me. But this ends this topic. So volume of solids of revolution for polar equations. By polar equations is the polar equation here. In this case, parametric equations be used here. Some Cartesian equation we have discussed, parametric equation we have discussed. This is now polar equation. That's all. Okay, then see you in the next lecture series.